Um, Another week of dinosaur paleontology. This week we are going to be in week 4, which is focusing on um, studying how dinosaurs moved, and then what does that information kind of tell us about maybe the metabolism of dinosaurs. Okay, so I'm going to walk you through what needs to get done for the week. We do have a lab this week, and a little bit different than normal. Everybody's going to do the lab the same way, whether you're at home or at school. So I'm going to walk us through that lab. So this video might be a little bit longer. Make sure you watch that video to the end, especially if you're a cohort C person. Okay. So taking a look at our weekly plan here, very similar to last week. We have our week 4 readings and videos. Make sure you take a look at those, take notes, so that the week 4 homework and the moving around quiz are easy to do. So you do have that week 4 homework revolving around the learning targets for week 4. Please make sure you cover all learning targets and you do so in enough detail. That's what I've noticed over the past couple of weeks. People that aren't getting a 10 out of 10 aren't quite covering everything, every single learning target. So please make sure you do that. That quiz is open note, and you can take that as many times as you need to. So please do that so that you can get that perfect 10 out of 10 there. And then this week also, I want to get us ready for an interview that we have with Dr. Hastings. He's a vertebrate paleontologist that is in charge of the paleontology collection at the Science Museum of Minnesota. So there's a brainstorm activity that I'm going to show you, and I'd like you to throw some questions in there, and then we'll kind of narrow those questions down. So when we see him on the 12th and the 13th, he'll walk us through some stuff, and then he can answer those questions that you guys ask. Okay, so you've got all week to do those things. And then, like I said, we do have a lab this week on determining speed of dinosaurs, which is based on tracks, which is something called ichnofossils. And that is going to be due a week from this Friday, so November 6th. All right, so those are our due dates for the week. Okay, I'm going to jump into the week 4 folder. The learning target checklist this week. Again, just wanted to bring this to your attention and make sure that you cover these. One thing that students are doing, which is helpful, is actually on your homework, you're putting in the learning target 4.1, for example, and then maybe putting in the sentence that goes with it. Okay, so we're going to take a look at the stance of modern dinosaurs compared to some animals that live today, to kind of help us understand how they moved. Again, we're going to compare, so doing some comparative anatomy, locomotion styles, looking at modern organisms compared to dinosaurs. We're going to look at and understand how we can interpret ichnofossils, or those trace fossils, to determine the type of locomotion. That is really the lab for the week. And then, like I said, trying to look at this idea of, once we understand the locomotion of dinosaurs, we can then understand maybe a little bit more about their metabolism, which is 4.4. Okay, so that's the checklist. However you want to do your week 4 homework, make sure you cover all of those. The readings are here. The videos are here as well. And then if you want to take a look at some of my presentations for the week, you can. Okay, quiz is there, enrichment reading. I'm going to open up the brainstorm. So what I've done in here is given you a couple of links that give you some background on Dr. Hastings. Okay, so it would probably be a little bit easier to write questions if you take a look at these couple of links, so that you can think through some of those questions. Okay. Otherwise, I want you to think of questions that you'd like Dr. Hastings to discuss. Focusing really on, maybe the education of a vertebrate paleontologist, going to school and what your majors would be. What is it like working in the field, in the lab? What is it like working the job that he currently has, other jobs that he's had? He has done a lot of publishing, maybe some questions about that. Feel free to ask him about dinosaurs. He's really into crocodiles, and I mentioned this before. He was on the team that helped describe the largest prehistoric or living snake, Titanoboa. If you have any questions about that process, that would be cool. So think it through. And then over here, I've got your name and then question 1, 2, and 3. Just type in 3 questions, and then we'll kind of whittle things down from there. Okay? So please make sure you fill in those 3 questions by Friday. And then the last thing I want to talk through is this determining speed lab. Okay, so when you open the lab up, down at the bottom is the link, which will take you to the lab itself. And I would say sending this over to Notability might not be a bad idea. Okay, so what we're going to do is take a look at some work done a while ago from Dr. Alexander. Okay, and he focused a lot on creating methods to determine speeds of dinosaurs based on biomechanics. So read through the background here, okay, because there's going to be some discussion about dynamic similarity and dimensionless speed. The definitions are there for you. What I would like to do is spend time walking through the process, okay, and how to do this. So whether you're at school or at home, you need a 30-foot area in a straight line because you're going to be doing some running and jogging and walking. If you have chalk or tape or something like that to mark off the starting line for your 30-foot area and your end line, you're going to need to do that. This week it should warm up later in the week, so hopefully we can get outside no matter where you are and do this. If you have people that you can work with, whether they're friends, siblings, parents, whatever the case is, having a couple of people with this is helpful. You don't need it though. You can do this all by yourself. Okay, so you're going to need a timer. Okay, so either use the timer on your iPad or your watch or anything like that. Okay, that timing is going to be important. Starting and stopping when you cross that line. If you have other people in your group, you're going to need them to kind of help mark off where your strides are. Okay. Otherwise, if you're doing this outside, which you really should be, you're going to need like water, and you're going to be using your shoes and stepping in water, and you're going to mark. You're just going to walk or run or jog, and wherever your wet foot marks are, that's where you're going to be marking with the chalk. So if you're doing this by yourself, you're going to have to work fast so that the water tracks don't dry before you mark down the data. Okay. So one person is going to be the runner. Okay. You're going to get your feet wet, and then you're going to walk, run, jog. You can choose how you want to start it. You're going to start the timer the second that you cross the start line, and then stop it when you cross the finish line, and then you're going to do some calculations. Okay, speed, remember, is the distance, so 30 feet divided by how much time it took that person to go over that 30 feet. Okay, and you're going to repeat this a bunch of different times, hopefully with different people that have different leg size and feet size, so that we can get some variation. And like I said, I want you to do this a couple of different ways: walking, running, jogging, okay, so that we get more data points. Okay, I've given you some calculations. Okay, so percent error is the estimated value subtracted. You subtract the actual value from that, and then divide it by the actual value and multiply it by 100%, and that's your percent error. Okay, so the true value is what you actually got for your speed in the lab. Okay, and the estimated value is the calculated speed. Okay, and I'm going to walk you through that process. Okay, all right, so here's what you're going to do. You are going to, first down here in the data table, trial description would be something like, Mr. Chrisman walking. Okay, so if it's a different person, you need to put the person and what they're doing: walking, running, jogging. That's the trial description. If it's just you, then just write me running, me walking, me jogging. Okay, you're going to need to measure your foot size. Okay, so you're going to need something, whether it's a measuring tape or something like that, to measure your foot size. Now, you're going to measure in feet, okay, but the note here is that you need to convert those feet into feet and then tenths of a foot. Okay, easy way to do that is just go to Google, Google search, feet and inches to decimal of feet, okay, and get something like this. Okay, I typed in 4 feet 7 inches. The decimal of that is 4.6, round it to the first decimal. Okay, 4.6. All right. So it's absolutely critical that you are not using inches, that you're using feet and then the tenths of a foot. Okay, so measure your foot size. Then you need to measure your leg length, so from your hip socket all the way down to your foot. Okay, that is going to remain constant for all of these different trials unless it's a different person. Okay, then what you're going to do is you're going to measure your stride length. Okay, so up here, what you're going to do is measure that stride length in the trackway. So this is where your wet shoe tracks are for. Okay, and a stride length, as you can see, is with the same foot. Okay, so in this case it's left foot to left foot, front of the foot to back of the foot. That is your stride length. Okay, it is not left foot to right foot, it's left foot to left foot. Okay, so that is your stride length. Okay, from there, as you can see, we've got our relative stride length. Okay, what you need to do then is, okay, actually that was your measured stride length. What you need to do then is calculate the relative stride length. Okay, so to do that, you're going to take your stride length, which you measured, and divide it by your leg length. Okay, that will then go down here into the relative stride length. And then from there, we're going to go into the next step and figure out what the estimated dimensionless speed is. So you're going to take that relative stride length that you just calculated. Okay, you're going to come into this graph and find where it is on the graph. And as you can see, wherever it is, then you're going to go over to the black line and then make a straight line down, and that is going to be your dimensionless speed. Okay, so that's how you figure out dimensionless speed. The next thing you need to figure out is the estimated speed. Okay, your estimated speed, so this is a formula. This isn't actually what happened in the lab. So that's this formula right here. You're going to take your leg length times gravitational acceleration, and since we're working in feet, it's going to be 32 feet per second squared. Okay, so whatever your leg length is times 32, do the square root of that, and then multiply that by the dimensionless speed that you just got from the graph here. Okay, so that is the estimated speed. Okay, the measured speed is just from that formula up at the top. It's distance over time, so 30 feet divided by how long it took you to do that, and then you'll use that percent error calculation up at the top to figure out that percent. Could be negative, could be really big, could be really small, but whatever it is, that's what you're going to put there. Okay, so if you get lost, just follow these steps here. Okay, use this graph. Okay, use Notability to draw those straight lines to get your dimensionless speed. Fill out that table, and then the last thing that you're going to do is answer the questions in 4. Okay, so that is the lab. It is due, like I said, a week from Friday, which is November 6th. If you have any questions, just let me know, and have a wonderful week.